So now we are discussing about isomerism in the complex compounds. Iso means same. Merism means exchange or different. So what is the same? Molecular formula is the same. What is the different? Properties are different. So same molecular formula, different properties. You called as isomers, that is called as isomerism. So isomerism is classified into two types. So mainly one is a structural isomerism. Next, second one is a stereoisomerism. So again, structural is classified into one ionization isomerism. Second, hydration, otherwise salvation isomerism. So third one, linkage isomerism. Fourth, coordination isomerism. Fifth, so coordination positional isomerism. Next, sixth one, polymerization. See the name itself, the change in the compound has same molecular formula, different properties through the difference in the structure. So stereo means that is a three-dimensional space around the functional group. Around the functional group, three-dimensional space is called as a stereo. So compounds have molecular formula, they are showing different properties through the difference in the three-dimensional space, otherwise stereo around the functional group. It is mainly classified into two types. One is geometrical isomerism, optical isomerism. So in geometrical isomerism, you must remember distance difference. So you given a molecule, you write down. If you are getting different distances are there, otherwise more than one structure is possible. So more than one structure is possible, then they will show geometrical. So optical means so plane of symmetry absent. So plane of symmetry is absent. So then that is showing optical activity. So in structural isomerism, so one by one we can see. So first one, ionization isomerism. So ionization isomerism means the compound have same molecular formula, they are showing different properties through the difference in the ions which are coming from the solvent or solution state. Suppose you take Cl2Br. Suppose you take this complex and you add into water. So then what happens? CONH3 taken for Cl2 plus, next Br minus. So in this complex, bromide ion is coming outside in the solution. Suppose, so you take CONH3 taken for ClBr, outside chlorine, you take into water. So you are getting CONH3 taken for ClBr positive. Next Cl minus ion is coming. See here, molecular formula both are same, but outcoming ions are different. Here bromide ion is coming, here chloride ion is coming. So that's why if negative ligands are there means directly you can tell it is showing ionization isomerism. Next, salvation. Solvent we are using. Solvent different. Salvation, otherwise hydration. So hydration isomerism. So generally the ionic compounds are showing hydrated molecules. See, suppose you take CO, H2O, taken 6, Cl3, 0 water molecules. Suppose you take CO, H2O, taken 5, 1 chlorine you put inside, 2 chlorines outside. Outside 1 water molecule, 1 hydrate, monohydrated complex. CO, H2O, taken 4, Cl2, 1 chlorine you take another this side. Chlorine inside means 1. So here 2 water molecules. Next, this chlorine also you take inside. H2O taken 3, Cl3 dot 3H2O. Suppose if you see these all complexes, formula is the same, but what? Hydrated. So it is a anhydride, monohydrate, dihydrate, trihydrate. Formula is the same. That. Next, linkage isomerism. So direct you remember linkage isomerism. You want means direct in the given complex contains ambidentate ligand. Ambidentate ligands are present. Direct you can tell it is a linkage isomerism. Ambidentate means what? Already starting only we discussed. So the ligand contains more than one donor, but anyway it is donated. So Cn minus. So Cn minus or Nc minus. So CnO minus, NCO minus. So instead of this CnS minus. So NCS minus. So you can take. So ambidentate. Next NO2. NO2. Otherwise NO2 minus, ONO minus. So nitro, nitrite. So ambidentate ligand is there means direct you can tell it is a linkage isomerism. Next, fourth, coordination. Coordination isomerism. See the name itself, coordination means metal surrounded ligands is called as a coordination. So that is a different. See, suppose you take nickel Cl4. Next, platinum H2O taken 4. Next complex, nickel H2O taken 4. Platinum Cl4. See these complexes. Nickel coordination is chlorine, platinum coordination is water. But formula is the same. 1 nickel, 1 platinum, 4 chlorine, so 4 water. But nickel surrounded here chlorine, but here nickel surrounded with water. Here platinum surrounded with water, now platinum is surrounded with chlorine. So the difference in the coordination of nickel and platinum. So that's why it is called as coordination isomerism. Next, coordination position. Coordination position isomerism. So coordination means metal surrounding is different. Next, position. So where this is observed, so that means it is in bridged ligands. So it is observed in bridged complexes. Bridged ligand complexes. You can see that one. So that means CO, NH3 taken 4, CO, OH, CO, Cl4, NH2. See here 4 negatives, here 2 negatives, total 6 negatives plus 3 plus 3. It is balanced, no need. Next here I am taking CO NH3 taken twice, Cl2. Next OH NH2. Next Cl2 NH3 taken twice. See, cobalt is surrounded with 4 ammonia. Cobalt surrounded with here 2 ammonia, here 2 chlorine. That means position, coordination is different. Next position also different. Here what? 2 ammonias, 2 chlorines, but here 4 ammonias. So that is coordination different, position also different. So last one in the structural, that is polymerization. So polymerization, so monomer, dimer, trimer, like that it is there, means you can tell it is a polymerization. So you take PtCl2 NH3 taken twice. Suppose you take this one. Next we can take PtCl4. Next PtNH3 taken 4. So that means what? Here 1 platinum, here 2 platinums, here 2 chlorines, here 4 chlorines, here 2 ammonia, here 4 ammonia. So exactly double of this one. So this is monomer, means it is a dimer. So anyhow it is a polymer. So like that. So now we will discuss about stereoisomerism. In stereoisomerism we have two. So geometrical and optical. So geometrical and optical. Two isomerisms. So here the two important coordination number 4 complexes. So we will see stereoisomerism in coordination number 4 complexes. So next here, coordination number 4 means we have two types of hybridizations are there. So one is sp3, another one is dsp2. So what will be the structure of this one? So it is a tetrahedral. sp3 is a tetrahedral. So you take L1, L2, L3, L4. So 4 ligands. Next, this is M. dsp2 is a square planar. So L1, L2, L3, L4. See, geometrical. Who is showing geometrical means distance difference. So here L1 to L2 close distance, L1 to L3 far distance. Distance difference is there. Distance difference is there. Next, you write more than one structure. So it means L1 is close to L2. So next one L2 you write here. So that means more than one structure is possible. More than one structure is possible. So who are showing these two? That is called as geometrical. So the square planar compounds are showing geometrical isomerism. The main condition is distance difference also possible. Next, more than one structure possible. Then they will show geometrical isomerism. Next, you come here. So this is what it is looking like. See, metal is the here. So here 1, 2, 3 above 1. Here to here same distance, here to here same distance, here to here same distance. So that means distance difference is not there. Distance difference is not there. So that's why it is not showing geometrical. So 4 different ligands are present, means it is showing chiral nature. So that's why because of chiral nature it is showing optical. Next, so here what? Plane of symmetry. You can't cut into two equal halves. So plane of symmetry is not there. Plane of symmetry is not there means that is optically active. So here what? It is exact plane only. Upon board only these are there. Suppose exactly you cut the molecule into two equal halves. So it is a plane of symmetry is possible. Plane of symmetry is possible means optically inactive. So that's why you can write the shortcut also in this. What that? GOSP opted. See, geometrical is showing by square planar. Geometrical is shown by square planar. Optical is shown by tetrahedral. So optical is shown by tetrahedral. GOSP opted. That way. So now one by one we will see. So this is already optical. So four ligands you take different in sp3. Direct it will show that optical activity. Now we will see the geometrical isomerism. So in this Ma4, so metal is surrounded with four similar ligands. So you can't write more than one structure. More than one structure you can't write means there is no geometrical. Next, you take Ma3b. Ma3b means M. You take 4. A, B. So you can't write more than one structure here also. So that's why it is not showing geometrical. C. M. A2, B2. So M you can write A and A same side. B and B. Next another possibility. M. A and A you can write opposite. So two possible structures. Cis trans. So that's why more than one structure possibility is there. So that's why it shows geometrical isomerism. Next, D. So you take Ma2BC. So two members are there. Two members close distance, two members far distance also you can write. So that's why it is showing geometrical isomerism. See, suppose in examination, how you can identify this means Ma2BC means, suppose we are taken nickel is the metal, Cl2 it is A, bromine that is cyanide upon -2. So this is exactly equal to metal A2 means Cl2, B plus bromine. Next another ligand, C is another type of ligand. So like this in examination they are asking like this, not this one. So based on this you can identify Ma2BC type and you can think about that. Next, if all ligands you are taken is different, MABCD type. So here you can't write cis and trans. So but it is showing geometrical. So because of more than one structure is possible. So that is what MABCD. So A is trans to B. A trans to B, otherwise A cis to C, A cis to D. Both are same only. Next, M, A, C, B, D. So here, A trans to C, otherwise A is cis to B and D. Next, M, A, D. You take B, C. So A trans to D, otherwise A cis to B and C. So you can write more than one structure. More than one structure means geometrical is there. But similar groups are not there. So that's why you can't tell cis and trans. Next, if you take bidentate ligands. So bidentate ligand, suppose M, AA. taken twice. Next, M, AB taken twice. So, AA, you can write M, AA, AA. So you can't write any other possible structure. So that's why it is not showing geometrical. Suppose here you take AB bidentate ligand, AB bidentate ligand. Next M, AB. Next BA. So you can write two possible structures, A trans to B, A trans to A. So both structures are possible. So that's why it is showing geometrical. Next, suppose bidentate, see AA means what? CH2, CH2, NH2. NH2. This is what? Ethylenediamine. Ethylenediamine is what? Same ligand. So that is AA, same. So you can take it. This is AB type. AB type means what? Glycinato. So CH2. NH2 is one donor. COO minus. So glycinato. So here A donor, this is a B donor. Different donors. That is AB. Next H you take M, AA, A2. So how you can write this one? M of AA. You can write AA. So here similar. So you can't write geometrical isomerism. Next, stereoisomerism. Stereoisomerism in octahedral complexes. Octahedral complex. Otherwise, coordination number 6. Coordination number 6 complexes. So coordination number 6 complexes. So here D2sp3, D2sp3 or sp3d2 has an octahedral structure. So at a time we will discuss geometrical and optical here. So geometrical means you must remember more than one structure possibility. Optical activity means plane of symmetry absent. Plane of symmetry absent. Geometrical means more than one structure. More than one structure is possible means direct you write is geometrical. So here different we are taking MA6. So metal you take central, write down 6. See, you can't write any structure extra. So that's why it is not showing geometrical. Next, you cut into equal halves. Plane of symmetry is there. Plane of symmetry is there means optically inactive. See, just this one you can imagine metal is the middle, 1, 2, 3, 4 are like this, above 1, below 1. You can imagine this one. Next, B. MA5B. M. You take A, B. So here, the B you can put anywhere, the same structure only. So more than one structure you can't get. So geometrical is not there. Next, you cut into equal. So these are what? 4 are here. Triple A, here B, above A, below A. I am cutting like this. So above A, below A. Plane of symmetry is there. So that's why it is optically inactive. Next, C. M, A4, B2. So then you can write in what way? See, A4. A4, B is above, B is below. So this is what? Trans. So same groups are exact opposite side. Next, M. So BB, you write beside. So this is cis. So cis trans, you can write two structures. So more than one structure is possible means it is showing geometrical. So this compound is showing geometrical. Next you think about optical. So this trans, you cut into two equal halves. So this trans compound is not showing optical activity. Next, you cut into like this. So exact half of it will be separated. So plane of symmetry is there. Plane of symmetry is there means optically inactive. Next one, Ma3B3. So you can write M. So 3 A's continuously you write down. Next, M. A. Give gap. So you can write two structures. This three continuous you called as a facial. Next, two are here, one is here. This is a meridional. So similar to cis trans, but here facial meridional we called as. Next, these are geometrical. So more than one structure is possible. So that's why these are showing geometrical. Next, optical you can think. So optical you can cut like this. What happens? Equal halves are coming. Next, where is the A here? Front is A, B is back side. You cut like this. So exactly plane of symmetry is there. Plane of symmetry is there means it is not showing optical activity. Next, see here above is A, below is A. So that's why you cut half of that one. So M is here, here BB, here AB. So above A, below A. You cut like this. So A and A both are perfectly separated out. Plane of symmetry is there. So that's why it is also optically inactive. E. MA4, you take BC. So here what happens? So BC, same close distance or far distance you can write. So directly you can write geometrical isomerism. Next, all you can take different. M, A, B, C, D, E, F. So 6 out of 6 are you are taken. So you are getting A trans to B, A trans to C, A trans to D, A trans to E, A trans to F, like that. So many you can write. So that's why it is showing geometrical. Next, every ligand is different. So in any direction you cut, so you can't get equal. So that's why it is showing optical activity. Next, we will take bidentate ligands. So bidentate ligands means you take M, AA taken thrice, M, AB taken thrice. So here M, AA, AA, AA. So here what all are A. So other structure you can't write. So it is not showing geometrical. Next, you must imagine. So M is here, A and A. Here one ring is there. So here, see this ring. This ring is means this side. This ring means so here to here one ring, here to here one ring. So you can't cut into two equal halves. So that means this is optically active. Very very important. So it is not showing geometrical but showing optical activity. Next, this one. So you can write AB, BA and AB. So A is opposite to A. So it is right as a trans. Next, M. So AB, BA, AB. See, it is a type cis type AA. So here what? Anyhow, two different structures you can write. So that's why it is showing geometrical isomerism. So above ring, below ring, already we seen. So this is only optical active, means both are optically active. So MAB taken thrice, it is showing geometrical as well as optical, but it is not showing geometrical, but it is showing optical activity. Next, you take mixed. So mixed monodentate bidentate ligands type M, AA taken twice A2. Suppose we are taking this one. So you can write as A and A very close distance. So A and A. Next, another possibility. Small a and A you write opposite. So then what happens here? A and A very close distance. So it is a cis. A and A opposite. So you write as a trans. Next, so you think about optical activity. So optical activity means this ring is not coincide with any ring. Above that one, two are there, below ring is there. So it is showing optical activity. So both are, it is showing geometrical. Next, here you cut into two equal halves. So that means this trans has a plane of symmetry is there. Plane of symmetry is there means optically inactive. So everything always you remember. So geometrical means conditions more than one structure. More than one structure you must follow. Next, distance difference. So distance difference in the ligands, otherwise more than one structure is possible means that must show geometrical. Optical means absence of plane of symmetry. So absence of a plane of symmetry. What is the plane of symmetry? Means you take the molecule in any direction, x direction, y direction, z direction, or any direction. You cut into two equal halves. It is happened means plane of symmetry is there. Plane of symmetry is there means optically inactive. Plane of symmetry is not there means optically active. So you must follow these two things and you can do that thing.